Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we look at the turning point form of a parabola. So this is to help us graph parabolas where the equation is of the form y equals a x plus h squared plus k. So it turns out these values a, h, and k tell us the transformations that have occurred to y equals x squared. So this value a determines whether or not the parabola has been reflected. So the parabola is a smiley face if this value is positive, a frowny face if it's negative. This value here, changing this value shifts the parabola left and right. You've got to be careful, it sort of goes the opposite way you'd expect. It goes to the right if h is negative and left if h is positive. You could be forgiven for thinking that positive means it would go right since the positive values are to the right, but it's not. To the right if h is negative, to the left if h is positive. This value here works the way that you'd expect. It shifts the parabola up and down. Up if it's positive number and down if it's a negative number. So this is the graph of y equals x squared, a very simple parabola. So if we're graphing functions like this, all we have to do is apply a simple transformation to this graph here. So let's look at y equals x plus 2 squared. So I've graphed here y equals x squared, the same graph as here. So y equals x plus 2 squared is exactly the same graph as this, except it's translated 2 units to the left. Here, my h value is positive 2, so positive means it goes to the left, and it goes to the left 2 units because this is 2. So this graph, exactly the same as the red graph, except shifted 2 units left. That means every point on the red graph is moved over 2 points to the left. But of course, we're not going to sit here and move all of these points. What I want you to think of this transformation is acting on the turning point. You see, for y equals x squared, the turning point is the origin, 0, 0. This is the turning point. This is where the parabola kind of stops and turns around. So what I'm going to do is move the turning point 2 units to the left. So the turning point, instead of being at 0, 0, it'll be over here at minus 2. This will be the new turning point for the graph y equals x plus 2 squared. Other than that, it's exactly the same graph as y equals x squared. So it's going to have the same shape and everything, it just looks like that. So let's look at this one here, y equals x squared plus 3. Well, this is the exact same as y equals x squared, exact same as this graph here, except every point is moved up 3. Once again, we're just going to move the turning point up 3. So it's going to be up here at 3. And other than that, it's exact same graph. It's just going to have the turning point there at 3. So what about y equals negative x squared? Well, this time we've changed the value in front of x squared. A is now negative 1. A is negative 1. If a is negative, then this is a reflection. So y equals minus x squared is the same as this graph, except reflected about the x-axis. Now, this hasn't been translated left or right. There's no constant term here. There's no value outside the brackets. There's no value inside the brackets. So I haven't moved the turning point left or right or up or down. The turning point's going to be in the same spot, but the graph is reflected. So it's going to look like this. So it turns out if we have a parabola in this form, we can find the turning point really easily. And that's what we'll do on the next slide. So because of what I said before, because this value shifts the turning point left or right, this value here tells you the x-coordinate of the new turning point. So you have to take the negative of this value to get the x-coordinate of the turning point. That's because it goes in the opposite way than you'd expect. Like I said, if this is positive, it moves the turning point left, and if this value is negative, it moves the turning point right. So that gives you the x value of the turning point. Remember, this value here shifts the turning point up or down. Up if it's positive, down if it's negative. So up or down, that's the y-axis. This value gives you the y value of the turning point. So if I see an equation in this form, I can get the turning point easily from these two values, and then all I need to do is calculate the y-intercept by letting x equal 0, and then I can graph them. Probably doesn't make a lot of sense. Let's look at an example. So let's say I want to graph this function here, y equals x minus 3 squared plus 2. This will have the same shape as y equal x squared, but it's been shifted 3 to the right and 2 up. So the turning point of this is the negative of this, so minus 3 gives us positive 3, 2. That will be the turning point of this parabola. So let's go and plot the point 3, 2. So, turning point of the parabola is here at 3, 2. So that's a really good start for knowing what the graph will look like. The problem is we don't know, will this parabola go like this, or will it go like this? So finding the y-intercept where it hits the y-axis here, that will help. So if I substitute in x equals 0 into this equation here, I get minus 3 squared plus 2. Make sure you put the brackets in your calculator. You should get y equals 11. The y-intercept is up here at 11. So it also goes through this point here. So that's enough to know what this graph will look like. Because it's got the same shape as y equals x squared, it's going to come down here, hit the turning point, and then stop and turn around and go the other way. So that's what the graph of y equals x minus 3 squared plus 2 will look like. So just get the turning point, find the y-intercept, and draw a parabola, same shape as y equals x squared. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.